1a, let f(x) equals this. The following diagram shows part of a graph of f. There are x-intercept at x equals 0 and x equals p. There is a maximum at a where x equals a, and a point of inflection at b where x equals b. Then find the value of p. Since this problem we can use a graphing calculator, I will show you on the calculator.
First of all, we will put a function into the calculator, y1. Then we go to graph. From this graph, you can figure out this maximum point and also this x-intercept. So we go to second trace. Let's calculate. First of all, we want to figure out the x-intercept. That's 0. So I press this 2, 0. Left bound means we need to put this arrow on the left side of this x-intercept. So we move the arrow to the left. Yeah, this is a left bound means on the left side of this x-intercept. I will put the enter. Right bound, so keep moving on the right side of this x-intercept. I will put the enter again, then enter. You could see your answer will be 2.73. That will be the x-intercept. Remember, we need 3 significant figures. Now we can work out this maximum point. Still go to second trace. Maximum, that's 4. So press 4. Left bound, still make the arrow on the left side of the maximum point. Enter. Then move to the right side of the maximum point. Enter. Then enter again. This will be the maximum point.
For 1c, write down the rate of change of f at a. We know a is a local maximum value. Therefore, the rate of change, which means the derivative of fx at a, equal to 0. Because for derivative means the slope of a tangent line. For 1d, find the coordinates of b. We know this b is a reflection point. According to the definition, the second derivative of fx equal to 0. So we will set up on the graphing calculator the second derivative of fx equal to 0 to figure out the x-intercept. That will be the x-coordinate of b. Now, I will show you how to use graphing calculator to figure out the inflection point. We go to y. We will put the derivative into y2. So go to math. Derivative will be 8, so I press 8. This will be x. We do the derivative of y1. So we go to variable, y variable, get the y1. Then for this x equals to x. This will be the first derivative of y1, which means it's a slope of a tangent line. We want to get the second derivative of y1. Therefore, we do math, find the derivative, that's 8 again. Here's x, But this time we need to put y2 because we do the derivative of y2. So variable, y variable function. Then here's y2. Then get this is x. If you go to graph, you will see 3 graphs. It's hard for us to decide which one is which one. Therefore, we go back to y equals. You can clear this equal. I see enter. Then the graph won't show the y1 and the y2, only show y3. For the y3, since this is a second derivative of fx, we want to figure out the inflection point, which means the second derivative of fx equal to 0. I need 0. So we do second trace, 0, enter. We know the x is greater than 0 from the given graph. So we need this point, this left bound. I will move a little bit closer to this x-intercept. That will be left bound. Left bound means it's on the left side of x-intercept here. So we do enter. Then keep moving to the right side of this x-intercept. That will be right bound. I put enter. Enter. You will get x equals 0. So many 9, that means x equals to 1. For 1e, find the rate of change of f at b. I will show you using calculator how to do this. So we go back to y1. y1 is original function. The second derivative of original function, that's y3. y2 means the first derivative of fx. We are looking for rate of change of f at b. Therefore, we need to use the first derivative. We quit. So you can go to y2 variable. Here's a variable. I need a y2. We know the x equals 1, so we put the enter. That will be 6. Another way to do this is will be math. We get the derivative, that's 8. Then this time, you need to put the y1 because we put the original function into y1. Then put over here x equals 1. You will get the same answer. It's really up to you which one you got to use it.